As we learned yesterday, the heart of algebra questions make up 19 questions out of the 58, or 33% of the total math section, and that is the largest section. So about a third of it is questions like these. So since we've been learning all this linear stuff all year, you need to keep slope-intercept form at the front of your mind. When you have word problems, label what x equals and label what y equals. So you may have to define the two variables and give them x and y on your own, but they might tell you what the letters mean in the problem. Remember that m is the number next to x, and you might see words like for every, each, per, or the word rate when it's talking about the number for m. When you're thinking about the number b, it's the one that's all by itself. It's just plain. It means the y-intercept, and it's usually the starting number, the initial amount at the beginning when time equaled 0, whatever you start with, or you're only paying it one time in a situation. Those numbers are the y-intercepts. So let's see if we can figure out which variables are which in the first example. This story problem is something where they give us some information, like the starting year, 2014, so we'll remember that. County X had 783 miles of paved roads. So I'm going to circle the 783 as well as the miles. So then the year after that, in 2015, the county began building roads, 8 new miles of paved roads each year. So automatically when I see that word each, it makes me want to multiply by whatever the variable is for years. Since I'm fairly confident this is going to be the m, I really want to put an x next to it. So we'll see if we're going to use x. At this rate, so we know 8 is the rate, so it's the slope for sure. If n is the number of years after 2014, so it looks like n is going to represent our number of years. So instead of using x, in this problem, we're going to use n. So we know our slope will have an n next to it. At this rate, which of the following functions f? So instead of using y equals, we're going to use f, and in parentheses, n equals. And we're just trying to figure out where f gives the number of miles of paved roads. Okay, so this is the miles. And n is our number of years. And the only other thing we need to include is, did we have a y-intercept? If they're building 8 new roads, or 8 new miles of roads every year, what was there at the beginning of this situation? Well, there were 783 miles of road already there. So this function matches up exactly with C. Well, not exactly, because they flip-flopped the numbers, but that's okay, because the n is still next to the 8, and the 783 is still all by itself. So 1A is C. This is an alternative that the SAT may ask. They may start out with the same info, that in 2014 there were 783 miles of paved roads, and then they began building 8 miles of new paved road each year. So times x, or if you want to use n like they did in the example above, you can. It's an x, by the way, each year. At this rate, so at the rate of 8x, 8 new roads every year, how many miles of paved road will County X have in the year 2030? Okay, we're trying to figure out how many miles. Miles equals question mark. Well, since our x variable equals the years, our y variable must equal the miles. So we're figuring out what y is. Let's not forget the rest of the equation, the fact that we started with 783 miles already there, and they gave us this in the year 2030? Well, this is the number of years since 2014. So in the year 2030, how many years have gone by since the year 2014? If you do a quick subtraction problem, you'll see that 16 years went by. So that's what we're going to plug in for the years. After 16 years, they will have built 8 new miles for each of those years, but we have to add on the 783 that was already there, and that will tell us what y equals how many miles, which is 911 miles. So we're going to go to the grid. I'm going to write 911. It doesn't matter that I'm leaving that last one blank. It's okay. And I'm going to bubble in the 9, the 1, and the 1. The SAT will score what you bubble in, but it's always a good idea to fill in those boxes just to be sure that you are bubbling in the right numbers. Here is a third take on this problem, another way they may ask you a situation like this. For the sake of saving time, let's go ahead and write our y equals 8x plus 783, just because we've already done it, where y is the number of miles of road paved, and x is the number of years since 2014. So let's make sure that we answer the question they're asking. They want to know in which year, all right, so our answer is going to be a year. When will the county have at least 1,000 miles of paved roads? So they don't want exactly 1,000 miles. They want at least 1,000 miles. It means the number of miles that they have, which is what's on this side of the equation, it needs to be greater or equal to, I guess, to 1,000. And since the 1,000 is miles, it's going to go in for y. And we're trying to figure out how many years. So let's do that. Let's solve this inequality by subtracting 783 from both sides. And we will get 217 divided by 8, and we're going to get a decimal. We're going to get 27.125 is less than or equal to x. That means the number of years has to be greater than 27.125 years. So give me a year that's greater than that many years. Well, how about the next biggest number? How about 28 years? So they didn't ask specifically how many years, they asked in which year. So the beginning of this situation was the year 2014. We have to add to it that after 28 years, there will be at least 1,000 miles of paved roads. And when we add all this up, we're going to get the year 2042. So we'll fill in 2042, and we'll bubble in the 2, the 0, the 4, and the 2. All right, I'm going to show you a pretty quick way to do number 2a. We're going to be using slope-intercept form again, so keep that in mind. We have a $50 charge for the first 2 hours that Miguel is editing a manuscript, and $20 per hour, so times x, after that. So how long would it take Miguel to edit a manuscript if he charged $370? We're trying to figure out how long. So x is hours, all right, so we're going to be trying to figure out what x is. And the cost is $370. So that is the total. So this whole thing equals $370. We know he charged $50 and that he charged $20 for every hour after that. So let's go ahead and solve this for x. Let's get rid of the 50, which leaves us with 320 equals 20x. When we divide both sides by 20, we get 16. Okay, let's make sure we're answering the question. This number right here, this X, is 16. The $50 took care of the cost of the first 2 hours. So he didn't work just for 16 hours, he worked 2 plus 16 hours, which is 18 hours. So in the box, we'll put 1 8, bubble in the 1, bubble in the 8, and that's all we have to bubble in. 2B is a variation on A. It's the same information. All they want us to do in this problem is find the equation. Find the equation if it takes them X hours to edit a manuscript where X is greater than 2. So he does edit for more than 2 hours, so it's going to be more than $50. So we already wrote down the equation y equals 50 plus 20x. So it would be tempting to pick C for our answer. However, when we figured out the answer to this problem right here, when we solved for x, when we solved that 50 plus 20x for x, we got a number that wasn't actually how many hours he worked, because he worked 2 more hours than that from the $50 charge. So if we know the real answer was 18, the number that goes in the x spot is 2 less than that. So if he worked for 10 hours, it means that this would be 8, because the additional 2 hours were covered by the $50 charge. Or if he worked for 20 hours, then this number would have been an 18, because the rest of the hours would have come from that too. So we're not going to have an x next to the 20. We're going to have 50 plus 20. We're going to have 2 less than that, x minus 2. But that doesn't really solve the problem either, because I don't see any answers that look like that. So what we have to do is we have to make our answer match what their answers look like. So I'm going to do that by distributing the 20. So that'll be 20x. 20 times negative 2 is negative 40. And we'll combine like terms and get 10 plus 20x. So that's what our function will be. So sure enough, the answer here is B. So let's talk about tax, because the SAT loves to ask you about tax problems. Your first job is to take whatever percentage your tax is and change it to a decimal by moving the decimal 2 places to the left. So if you start with the number 6, swooping it over 2 places left will give you 0.06. Or if you start with the number 20, the decimal's over here, you're going to swoop it over 2 places, and you get 0.2 or 0.20. So here's how stores show sales tax on your receipts. They multiply the price of your item by the decimal, and then they add it to the original price. So if you are buying a $10 shirt and the tax is 6%, you take your $10 shirt, you take that $10 and you times it by the 0.06, because that 6% is a decimal. So you get 10 plus 60 cents. So your total is $10.60 for the shirt. The SAT does it in one-step tax calculations here. So they still convert the percent to a decimal. You have to do that. But then they just take the price of your item and they multiply it by your decimal with a 1 in front of it. So if you have a 6% sales tax, you're going to multiply your item by 1.06. Or if you have a 20% tax, it'll be multiplied by 1.20. So we have a $10 shirt, multiply it by 1.06, and we're already done. We have the answer, $10.60. I'd like to give you a couple hints about the setup of this problem. We have Mizea buying pants and a briefcase. So I'm just going to go through and put a P and a B for pants and briefcase. The sum of the prices, so when we add those 2 prices up, before sales tax was $130. All right. There was no sales tax on the pants for whatever reason, but a 9% sales tax on the briefcase. The total, so when we add up, that he paid including sales tax, so that 9% on the briefcase, was $136.75. We're trying to figure out how much the pants cost. All right, that's our job. P equals what? How much are those pants? So I'd like to point something out. We have pants in a briefcase. We have before tax equals 130. We have after tax equals 136.75. So we have two totals here. We have two equations. So this is going to be a system problem. So let's write the very first thing they told us. Just the sum of the prices without any tax was 130. So however much the pants cost plus however much the briefcase cost, it equaled $130. Great, we have the first equation done. Next, it tells us there was no sales tax on the pants, so again, it's just going to be a plain P, but we have to multiply the briefcase by our 9% sales tax. So we're going to do the little trick that I told you up there, which is to change the 9% to a decimal. So it starts right here. We're going to swoop it 2 times. So the decimal's 0.09, and we're going to put a 1 in front of it. So that's what we're going to multiply the B by. We're going to write down 1.09 times the briefcase price. So once we included that tax, the total was $136.75. So pants and briefcase, no tax is $130. Pants, no tax, 9% tax on the briefcase. This is the total with tax. All we need to do is solve this system. So what are we going to do to solve this system? It looks to me like it's set up perfectly for one of your favorite methods, elimination. We can get rid of these p's if we subtract the equations, because p minus p goes away. Now our job becomes doing 1 minus 1.09, so that'll leave us with negative 0.09. B. 130 minus 136.75 is negative 6.75. So we'll divide both sides by negative 0.09, divide by negative 0.09, and we're going to get B equals 75. That means the briefcase was $75. What are we trying to figure out? We're trying to figure out what P equals. How much were the pants? So I'm going to take this 75 for B, and I'm going to plug it in right here. So the equation is P plus our 75 equals 130. So when you take away 75, you get that the pants cost $55. So we put a 5, bubble in the 5, bubble in the 5, and we're done. Problems involving distance, rate, and time are going to come up a lot on the SAT. And here's why, especially in the Heart of Algebra section. Rate is another word for slope. So whenever you see the word rate, think slope, think the letter M. All right? And then we have 2 other variables, distance and time. So these all kind of fit into our y equals mx plus b format. So distance equals rate times time. That is the equation. And here's a real quick thing you can think about. If you have driven 60 miles in your car and you are traveling at 60 miles per hour for your rate, how long have you been driving in the car? Well, 60 miles per hour, you've traveled 60 miles, you must have been traveling for 1 hour. So this is where we get the D equals RT. We don't always want it solved for D. Sometimes we want it solved for R. To do that, we'll divide, because these are multiplied, we'll divide by T to cancel it out. So R equals D over T. Similarly, we can solve for T by getting rid of the R that it's multiplied by, and T equals D over R. So we will use these in this next problem. here's what we're going to do. We're going to read through, and since it's multiple choice, we can already tell that our answer is going to be a system because there's 2 inequalities in each answer. So let's see which one has some of the right inequalities. We have every morning, John is jogging at 6 miles per hour. So I'm definitely going to circle that. 6 miles per hour. Guess what that is, since it's miles per hour? That is a rate. And I'm going to put a little J right there for jogs. Okay? And he rides a bike at 12 miles per hour. So the rate on the bike is 12 miles per hour. That's our rate. And he's biking. His goal is to jog and ride. So he's doing these things together for a total, when you add 2 things up, you get a total of at least 9 miles. So 9 miles is how far he wants to jog and ride his bike. He doesn't want to go exactly 9 miles. He wants to go at least 9 miles. So we're going to have something being greater than or equal to 9. All right. So just by looking at that, we can already get rid of choice B and choice C. All right, because we need it to be at least 9 miles. 9 miles. He also needs to complete all of this in less than 1 hour. He can't be out there all day. All of his activities need to take less than 1 hour. So some other inequality needs to be less than 1 hour. All right, well, if you look at A and you look at D, they both have less than 1 hour. So we've narrowed it down to 2 choices. If you have to guess from this point on, narrowing it down to 50-50, and guessing from there is a lot better than just guessing out of 4, but we'll keep going to get the rest of the right answer. So it says John jogs J miles and rides his bike B miles. So since J is miles and for jogging and B is miles for biking, I'm going to put the J and the B in the equation with the miles. See how I'm not going to put it down here in the hour inequality? I'm going to put it with the 9 miles. So we have all the miles together. So J plus B is greater than or equal to 9. Well, guess what? They both had that. So there we go. We have to figure out which inequality deals with the hours. So hours is time, right? We have the time variable. Just like we had miles right here, that was a distance, and J, it was miles, which is a distance, and B is miles, which is a distance. We need everything over here to be in terms of time. So if you look up here, time is the distance over the rate. So we know the distance that he jogs is represented by the letter J. So the distance is going to go on top. We know the rate that he jogged was 6 miles per hour. So the 6 goes on bottom because that's the rate. So we're going to have J over 6. We're going to add it to the time it took him to bike. Well, we need the distance he was biking on top. The distance is B, and the rate at which he was biking was 12 miles per hour. So we have B over 12, and you can see that the answer to this is A.